Hey guys, so tomorrow we're gonna be writing our final chemistry exam at 5 p.m. So I just thought maybe I could like give you some last minute hacks or tricks, or you could maybe figure out something that you actually overlooked whilst you were studying your chemistry that might be useful in tomorrow's exam today, and also just some confidence boosting. So yeah, let's get started. So I'm going to just look at the past papers that we were given, and yeah, everybody already worked them out and stuff. Just gonna go over them again a little bit, and some of the things that I was getting wrong, maybe you were also getting them wrong. So I'm just going to talk about those things in a little bit more detail so that you guys don't make the same mistakes that I was making when I tried these question papers. And the trend is the same. There's a pattern between the 2018 and the 2019 question papers. There's you can't deny the fact that there is a pattern, especially in section B. It's like number one is about some empirical formula, then number two is about the limiting reactant, and then there's some KBKA stuff, and then the last question is mostly electrochemistry, and you might get asked a little bit of things about periodic trends, and the quantum numbers are just showing up, right? So there's kind of like a pattern. So from those two question papers, there's stuff that confused me. I think that maybe, well, I'm gonna share it with you guys. Maybe it was also confusing you guys. So let's get started. Well, number one, all you have to do is to know your ions. Yeah, basically that's it. So what I did is I memorized the chlorate. Chlorate is ClO3 minus, as you can see, right? And then the one with the most number of oxygens is ClO4 minus, and that's perchlorate. And then the one with the least number of oxygen atoms is hypochlorite. So P is above H in the alphabet. The one with the most is per, then the one with the least is hypo with 1. And then from when we move down, when we go down by 1 oxygen, we're now ITE. So COO2 minus is chlorite. Yeah, that's what I use there. And then this one, everybody can calculate oxidation number. Just the oxidation number of oxygen is always -2. There are 3 oxygens plus X because we do not know the oxidation number of bromine. So let it be X, and the overall oxidation number is -3. That's how you do that one. And for this type of question, 4D, I just want to specify 4 is for N, and then L tells you the orbital that you are in, right? So L can be 0, 1, 2, or 3, and L should be, if N is 3, then L can be 2, 1, or 0. N and L cannot be equal. L is 1 less than N or more or less, okay? And L cannot be negative. So how do you know the value of L for the different orbitals? I do this thing of mine. I write speed, that's SPD, and then F on the bottom, and then 0, 1, 2, 3, opposite S, P, T, and F. So I know that the value of L for the S orbital is 0, for the P is 1, D is 2. So I use that speed and F at the bottom. So you could use that hack too. So for D is 2, so L is 2, so 4 and then 2. And then we know that ML is from minus L to L. So yeah, you can definitely take those out. Half is not in the range of -2 to 2. 3 is bigger than 2, so it's out. Yeah, that you could use that thing if this is confusing you, which I doubt that is confusing people. A lot of people are so good at this writing things. I mean, classifying the main reasons for the difference in the sizes of atoms. People know how to do that stuff. Then this question, the molarity of the solution, all you need is the number of moles of iron 3 sulfate, right? This one is not tricky. It's tricky when they ask you the total molarity of the ions. That's when you have to consider the concentration of iron 3 plus ions on their own, and then the concentration of the sulfate ions on their own. Okay, how? And so you're going to Well, that comes in the next question paper, so I'll talk about it then. And then in these types of questions, well, you just have to check in your reaction. Lead here, it's a reactant, there was a product. So if that's the case, you reverse that reaction, and also you reverse delta H. And oxygen is still a reactant there and there. What do? It's now half of O2. There it was O2. So you multiply that delta H by half, and then you add them. That's how you do that one. And then this one, we are told that the reaction is spontaneous and exothermic. Exothermic, it means that it emits heat to the environment, right? So I use a hack. Exo, that's like exit. Exo, so that's like exit. So exit means heat is getting out, is giving out heat to the surroundings, right? And then endothermic, I take that endo as in. So in an endothermic reaction, this thing is absorbing heat from the environment. Heat is getting into the reaction from the environment. In an exothermic, heat is exiting whatever. Heat is leaving our reaction and going to the environment. It's exiting heat to the environment. So what happens when a reaction is exothermic? That means that the surroundings are going to gain heat energy. So the surroundings entropy is going to go up. Okay, so we know that entropy of the universe is equal to entropy of the surroundings plus entropy of the system. So since this is an exothermic reaction, the surroundings entropy is going to go up. This is for the surroundings. I was told that the reaction is spontaneous, so delta H of the delta S of the universe is positive. So the entropy increase in the surroundings is going to be large, and then there's going to be an entropy decrease in the reaction since it's exothermic. But then for this to be spontaneous, we need an overall positive, right, change in entropy. So the entropy change of the surroundings has to be, the increase has to be way larger than the entropy decrease of the system. These delta S blah blah blah, they don't work, because if your delta H is negative and your delta S is positive, delta G might not be negative. Temperature is going to affect that. Delta S of the universe, it has to be greater than 0 actually. So that one is a big lie. This one is also another big lie. I mean, delta G has to be negative for the reaction to be spontaneous. And people are good at this. And then this one is cool. It might come, I don't know. You just need to know everything. So when a liquid is dispersed in colloid. A colloid is something that is between a solution and a suspension. A solution, salt and water, that is a solution. And then a suspension is like mud in water, that is a suspension. So colloids are in between. We've got different types of colloids. An emulsion is just a liquid dispersed in another liquid. Okay, so this is the correct answer. Think about milk. Think about mayonnaise. That's an emulsion. And then for gel, just think about the one that we eat. Okay, that is basically a solid dispersed in a liquid. Okay, a solid dispersed in a liquid. If it's gonna be hard to cream, just think about how you make the gel. You've got a solid, right, and then you just put it in water, and then you make the gel. So it's a solid dispersed in a liquid. And then in aerosol, think about I don't know, smoke. Yeah, the one produced by a fire. So there's some solid particles dispersed in a gas. We're dispersing stuff in a gas. Think about your perfume spray, right? Liquid dispersed in a gas. And then for a foam, think about marshmallows. A marshmallow, just when you look at it, it really looks like we are forcing gas into a solid. So a foam is basically a marshmallow, is basically gas dispersed in the solid phase, right? Yes. So for colloids, we've got the dispersion phase and the dispersion medium. What are we dispersing it in? That's the medium. So that's all that tricked me in section A for this paper. And then this question. Oh, you do not have to be lazy. You should not don't ever be lazy for these types of questions. Just do the whole thing. This is the anode and that's the cathode. The anode is always written here. The cathode is there, and this is where oxidation happens. And this is where reduction happens. Remember, your red cat, reduction happens at the cathode. I use that all the time. Use the red cat and write down the whole reaction. Aluminium is going to become aluminium 3 plus 3 electrons, and